A hospital pharmacist receives a prescription for 3% saline for a patient in the Neuro ICU. The premixed 3% saline bags that the pharmacy normally stocks are on backorder. How many milliequivalents of 23.4% sodium chloride will be needed to be added to a 1 liter bag of normal saline to prepare 3% saline for this patient? Molecular weight of sodium equals 23. Molecular weight of chloride is 35.5. So let me give you a visual example what it looks like. So here's my drawing of a saline bag. So this is 1,000 milliliters of normal saline, also which is 0.9% sodium chloride. That's normal saline. And I'm going to be adding to this 1,000 milliliters, which is a fixed normal saline bag. I need to figure out how much milliliters of the 23.4% sodium chloride that I'm going to need to add. So for sure, there's a fixed amount, 1,000 milliliters of the normal saline, which is 0.9%, and you're adding a certain amount of 23.4% to make. You want to make a 3% sodium chloride solution. That's your goal. Your goal is to get this. So you have to figure out how much of this to add. Well, actually, first you gotta calculate in milliliters, and then you're gonna convert it to milliequivalents, because your final answer is in milliequivalents. But you need to figure out milliliters first. So to do that, I'm going to use Alligation. How much of each of these two to use? So I'm going to use 23.4% because that's what we have. And then we also have a normal saline bag. Normal saline is the same thing as 0.9% sodium chloride. That's why I put 0.9% here, right? So you have these two in stock, and you're trying to make a 3% solution, right? Because that's what they want, 3%. That's why this is in the middle. And then you just go through the lines and subtract them from each other. So 23.4 minus 3, that equals 20.4. That's how much parts of this you're going to be using, the normal saline, 0.9% sodium chloride. And then now I'm going to subtract 0.9 by 3 and follow this line up here to get 2.1. So that's how many parts of that I'm going to use of the 23.4%, which is the top half here. And so now I'm going to add these two together. 2.1 plus 20.4, that equals 22.5 total parts. So I like to put this in, like, divide them by this, 2.1 divided by 22.5 parts, because that's like the fraction of this. 2.1 divided by 22.5 parts, that's a fraction of this 23.4% solution that I'm going to be adding into this. That's the total amount that's going to be in this final bag here. And also for this bottom half, 0.9%, it's the fraction of that amount is 20.4 over 22.5 parts. So you actually don't need to calculate this bottom half, because the question only wants to know how much of the 23.4% you're adding. So this bottom half you can just ignore. Just the top half you need. So I'm going to multiply this amount by the total end volume. That would be in this bag here. Because right now I don't know what's the amount here. So I'm going to put a variable n equal to the amount in milliliters of the 23.4% sodium chloride in final bag. Right, so that's why I'm going to multiply this by 1,000 plus n. Right, because that's a total n volume here. Because 1,000 milliliters you have to use, because that's the initial bag we use, because we have to start with this 1 liter bag of normal saline. So 1,000 milliliters is total volume at least. And we're adding 23.4%. But how much? We don't know. That's why I set that to N. So the final bag here, inside this whole bag, the final bag is 1,000 milliliters plus the N milliliters. That equals your total. And I'm going to set this equal to N, because this top half here represents the amount of the 23.4% I'm adding. That's why I can set this equal to N. So then when I solve for this, let me bring all this down here to make it easier for you to read. So now all I have to do is just solve for N. So the first thing I'm gonna do is just factor in this fraction here. So this fraction, 2.1 divided by 22.5. And then I'm gonna multiply that by 1,000, and then also multiply that by N. So that equals 93.3333333 plus 0.09333333. I'd always keep as many decimal places as possible to the N. That equals N. See, I just multiplied this 2.1 divided by 22.5. I multiplied by 1,000. And then I also did 2.1 divided by 22.5, multiplied by N. So that's what you get here. See? That's what I just did, factor that. So now I'm going to subtract this from both sides. I got 93.333333 equals 0.90666667 N, right? Because this N is just like one N, like there's a one coefficient, but you can't see it. So 1 minus 0.0933 is equal to 0.906 repeating N. So then you just divide both sides by 0.906766 repeated. So your N should be 102.941176 milliliters, right? So that's your total amount of milliliters that we need to add here, right? So this here is what I just solved. But remember, the question's asking milliequivalents. So to solve for milliequivalents, you have to use a milliequivalence formula. So you have to memorize milliequivalence equals milligrams times valence divided by molecular weight. So you just have to memorize this formula here. So now I'm going to solve for the milligrams. So we need to know how many to find out milligrams, but we just have milliliters. So 102.94 milliliters, we need to convert that to milligrams. So this is how much of 23.4% needed. Right, so now I'm going to convert this milliliters to milligrams, because that's what's needed in this milliequivalence formula. So I'm going to take 102.941176 milliliters, multiply that by the percent strength, which is 23.4 grams over 100 milliliters, right? This is the same thing as 23.4%. So milliliters and milliliters cancel out. So that equals 24.08825352 grams. But I want milligrams, so I just multiply this by 1,000 to get milligrams, which is 24,088.2352 milligrams. right? So I just plug this number into this milligrams here. And then multiply it by the valence. So the valence is going to be 1 because sodium is +1 and chloride is -1. So that's just 1 as a valence. This is just 1. And the molecular weight would be 23 plus 35.5 because there's 1 sodium, which is 23, and 1 chloride, which is 35.5. That's where I got these two numbers from. So I just add these together to get molecular weight. So this is all divided by the molecular weight, which is 23 plus 35.5. And then when you solve for that, you will get 411.8 milliequivalents. And this is your final answer. And in the computer, they say numeric, no units or commas, and round final answer near is 10. So just remove the milliequivalents, and that's your answer. Goodbye.